Good day to everyone. So we have here a continuation of our topic in stack and queues data structure. In our previous video, we have discussed about stack data structure rather, I'm sorry. And we will continue now with a different but similar data structure, which is called queue. And we will discuss its applications and how it is implemented in an algorithm. And on our next video will be the demonstration of implementing Q in a Java programming language. I am Mark Van Buladaco and I am from Davao del Norte State College. So without further ado, let's start the lecture video about queues. So queues is basically a common term for forming a line of objects or elements or even people. So it it grows by adding objects or elements to its end, and it can be shrunk by removing those objects or elements from the front side or the front of the list. It is different from stack because we know that stack can only be inserted. We can only insert an object on top, and we can only remove an object on top of the list using stack because of its LIFO principle. Queues can In a queue structure, both ends are used. The one end, which is the the front end, it is used for adding new elements. So we basically add up the list. Usually this is in the back, sorry, rather back end of the list or the queue list, and one for removing the elements. So we have the front for removing or accessing the elements, and then we have the back end, which is you put or insert new elements or objects. Therefore, the last element has to wait until all elements preceding in the list or in the queue are removed. So this is different from stacks. As we all know, again, stacks implement last in, first out principle, while queues implement first in and first out principle. So this is a visual example of a queue. It's basically a waiting line of objects. In this case, this is queue for people. So we have here at this part, these are the front end of the list or the queue, and this is the first person that will leave the queue because he or she is the one who enters first the queue. So that means he will be the first one to leave the queue. So we have here another person in the middle. So let's just think that these are the elements of our queue. And when there is a new person that will enter the queue, it will inserted or the person will be added to the back of the queue. So same with stacks, queues also have operations to different programming languages of how the queue will behave. So these are the common methods or operations that is um, somehow similar across different programming languages. So we have here the first two, which is the same with stacks. We have the clear method or operation that will remove all the elements inside the queue. And then we have the isEmpty operation that will check the queue if it is empty. Now, if it is empty, it will return a value of true. Otherwise, it will return false. Then we have an important operation here, which is the NQ. In the NQ method or operation, you need to specify the element you want to insert to the queue. So basically, the operation NQ will insert the specified element to the queue, which is basically at the end of the queue. And then we have the another important operation, which is the DQ operation or method. You uh, so we have an NQ to insert. So we also have a DQ to remove. So when you remove in a queue, since it is a first in, first out, so the first element who entered the queue will be the first one to be removed. Okay, so when you execute the DQ operation, you will take out the first element or the element in the front from the queue. So we also have similar to the stack operation, which is the first L. And the stack, if you can remember, we have the top L um, operation. So that means in stacks, the top L operation will um, return the topmost element in the stack. Now, in our queue, we have the first L. It will return the first element in the queue. That means the element on in the front of the queue without removing it. So I would like to remind everyone that all of these operations is basically a common operations, and it has a different implementation across programming languages. It doesn't really mean that the NQ term or the NQ identifier will be used as method as the actual method or operation for inserting or putting elements at the end of the queue. So this is a visual representation of how queue works in programming. So at first the list is empty. So as you notice here, it is empty. So there is a first execution of operation, which is NQ, and we have a specific element to NQ, which is the integer 10. So the integer 10 will then be inserted at the end of the queue. So basically, it is also considered as the first element or the element in the front because it's the only element. And then we NQ another element, which is the integer 5. As you notice, the integer 5 is inserted at the end of the queue. And then we do have now two elements on our queue. Now, another execution of the an important operation, which is the DQ. So DQ will remove the elements at the front of the queue. So when you DQ, you will remove the front element. So our current front element is the the number or the integer 10, and then we have another NQ operation to insert the integer 15. So integer 15 will be inserted at the end of the queue, and then we have another NQ here to NQ the integer 7. The integer 7 will now be inserted in the at the end of the queue. So as of the moment, we do have three elements on our queue. The front element, the current front element is 5, and it followed by 15, integer 15, and integer 7 at the back of the queue list. Now we have another operation of the dequeue operation. So when we dequeue, we remove the frontmost element. So at the current, our frontmost element is 5, so it will undergone dequeue operation. So the integer 5 is removed. So we do have only the integer 15 and 7. So that's how the NQ and DQ operation of queues works. So it's very simple. It's similar with stack. However, in stack, you push the element on top of the list and you pop elements also at the top of the list. An algorithm that is popular in implementing queues is the acrostic indicator algorithm. Now, um, in order, it is an application of queues wherein we consider the poem written by Lewis Carroll. So let me read the poem. Round the wondrous globe I wander wild. Up and down hill, age succeeds to youth, toiling all in vain to find a child, half so loving, half so dear as Ruth. This poem is dedicated to Ruth Dime, which is indicated not only, the first name is indicated not only at the last part of the or the last word of the poem, but also by reading it in the sequence of the first letter. As you notice, the first letter of each line corresponds to the characters of the name Ruth. We have here R and then U, T, and letter H. So R, U, T, and H, it forms the word Ruth. And the last word of the poem is also Ruth. This type of poem is called acrostic, and it is characterized by initial letters that form a word or phrase when taken in order. So to detect whether a specific text or a poem is an acrostic poem, we basically devise a simple algorithm in detecting or identifying it. We basically read the poem into the program, and Echo prints the poem and retrieves and stores the first letter from each line. We put it in our queue, and after the poem is processed, all of the stored first letters are printed in order. Now, this is a very simple algorithm. We call it as the acrostic indicator. So we have here just a simple algorithm. So we have here a while structure. Its condition if the program is if the poem is not yet finished being read or being fed into the loop, or the end of the line is not yet reached, it will read each line of a poem. Now, so if the condition will evaluates to true, it will read the line of a poem, and the first letter of the line will be NQ to our queue list, and then basically output the line. So So this will um, repeated until all of the lines are read, or the end of the file or end of the text is reached. Now, when all of this, when the first looping structure is terminated, all of the first letter of each lines are basically inserted in the queue. So while queue is not empty, so we will now this looping structure will basically print the letters from the queue list. So we will dequeue the queue list and then print the letter. So basically, when you dequeue, you dequeue or access the frontmost element and then remove it from the queue. At this example or this algorithm, you basically dequeue the frontmost element and then access it and then print the frontmost element to our program. Another example of an application of queues is the priority queues. So in some situations, simple queues are inadequate for implementation. So first in and first out scheduling has to be overruled by another scheduling principle, which is which implements priority criteria. That means those elements that are inserted in the queue will be tagged with a priority. So there will be another information of the element of what it is, what its priority. Example, when we insert an integer 10, we put priority on it. So in most cases, priority could be high, middle, or low priority. In a post office example, a handicapped person may have a priority over others. So in the Philippines, so when you are in the banks, the pregnant women, the PWD, and the senior citizen are given first a priority even though they arrive late in the queue. So this is an real world example of priority queues. So in priority queue, the sequence of let's say for example, we have process P2 may be need to be executed before process P1 for the proper functioning of a system, even though P1 was put on the queue of waiting processes before P2. In situations like this, a modified PQ or priority queue is needed. In priority queues, elements are dequeued according to their priority and their current queue position. So we'll now proceed to how queues are utilized in Java programming. So same with stacks. Queues is under Java.util package, but it has a somehow different implementation. Um, queue is an interface class. And as I said earlier, it is available in the java.util package and extends the collection interface. So what is an interface class? An interface is a reference type in Java. It's basically similar to a class, so we could call it a class. It is a collection of abstract methods, and a class implements an interface, therefore inheriting the abstract methods of the interface. In this case, we'll be using some collection interface from the java.util. So the queue is used to insert basically elements at the end of the queue and removes at the beginning of the queue. So we remove at the front, we insert at the end. Again, it follows the FIFO concept or first in, first out. principle. The Java queue supports all methods of collection interfaces. So basically, you can insert, you can remove, you can search. So there are three implementations of queue interface. So using under the collection interface. So we have the linked list implementation. So we could implement the interface of linked list. And then we have the array blocking queue class and the priority queue implementation. So if any null operation is performed on the blocking queues, there will be a null pointer exception is thrown because queue interface is a difference is a reference data type implementation. So if the pointer of those address is null, so there will be a thrown exception. But the most common utilization of queue interface is the linked list implementation. So this is a simple declaration and initialization of a queue interface. As you notice, we write first the queue um, class or interface class, and then we have here our identifier of our queue. My queue equals new, the new keyword in order to initialize, in order to call the constructor of the linked list and initialize us execute the initializations of the queue interface. So this is how you implement queues using the linked list interface. So there are methods in our queue interface implementing linked list. So we have the add. So basically um, since this is a linked list implementation, so we need to consider also the head, the term that is ahead, and the tail. So the head will basically the front of the queue and the tail is the end of the queue. So the add method will just insert elements at the tail of the queue. We have the pick method. So it will just return the current head of the queue, which is the current front element of the queue. And it will not remove the current head element. If the queue is empty, it will just return null. We have an element method. This is similar with pick, but if the queue is empty, it will throw an exception called no such element exception. We have the remove um, method that is implemented in linked list. So this is the DQ um, operation in linked list implementation, the remove method. So it will just basically remove and returns the head of the queue and remove it from the queue. If the queue is empty, it will then throw an exception called no such element exception. We have another method that is called poll method. So this method removes and returns the head of the queue. So somehow similar with the remove method, it also returns null if the queue is empty. Lastly, we have the size method. It will just return the number of elements in the queue. So these are just the basic methods in the queue interface implementing linked list. So there are also other methods that can be utilized by the queue interface because of the linked list implementation. So let's remember when you enqueue using linked list implementation, you basically use add. When you use add method, you need to specify an element you want to add to our linked list. Since this is a linked list implementation, so you could add a different type of data or different data types elements. So you could add first a boolean value, and then and the next um, object or element to be added will be an integer, another one is string, and so on. And then our dequeue operation is represented by the method remove. So that's it for our theory about queues. So we'll be discussing or further the implementation of queues using Java programming language. So the next video will be a demonstration of how to create a program implementing queues. So make sure to download and install your Java runtime environment and install NetBeans, since we'll be using the um, NetBeans for creating our programs. Thank you for listening. I will see you next time on our next video.